when I say winning numbers. Like you pick 5 numbers and you hope that you get all 5 so you can win the bazillion dollars that they're offering. They don't have to be in order. If they were in order, that's a harder problem. That's a lot more ways that you can get wrong. There's only one way to get it right. And so you're going to look at the difference between the two. Does order make a difference or not? And we have 2 particular counting methods that we'll get to at the end of 5.4. So let's just get started. So you go into a store, you want a shirt, and all they have is an option when you go into the store, long sleeve, short sleeve. You have no other choice. Okay, that's all they got, long sleeves and short sleeves, t-shirts, and all they got is 3 colors. That's it. You don't have any other colors, black, white, and red. And then the image that they could put on would be either no image, like leave it plain, or you bring in your own custom image, the one that you have. So you could get a long sleeve, a black shirt, and the image you brought in. That's one arrangement, one choice. And as you can see, I've listed all the choices in out. For instance, this is the first thing you have to pick, by the way. You have to pick your type of shirt. This is the second thing you pick. And that's the third thing you pick. So that's why you see it's either long sleeve, short sleeve to begin with. And then you got your color, black, white, red. So if you listed them all out, and that's what you're going to do, it's called the sample space, of course. You've got to come up with a sample space. And sometimes the sample space is just ginormous and there's no way you can come up with the sample space. So with those kind of problems, it's just, well, how many do you have? If when you submit your sample space, how many would be in your sample space? Like here, it's 12. There's got to be 12. And I found them. I found them all. But the whole scenario that I said, hey, Joe is up in the upper left-hand corner. Everybody wants to be in the upper left-hand corner. And Joe wants a chance to be in any other place. So how many different, well, gosh, I'm going to tell you how many arrangements there would have to be, how many outcomes there would be. That's all we're looking for, how many. And then don't try to figure out the sample space. I'm using the sample space to show you or demonstrate that if you count 12, that you can get the 12 a different way as well. You don't have to figure out every single item. You just get to know the process to know how many items or how many outcomes there are. So looking at the problem we just did before, you have 2 choices for sleeves. I mean, you have a long sleeve and a short sleeve. So you have 2 choices. And you have 3 choices for color, and you have 2 choices for your image. And if you multiply those 3 numbers together, you get 12, and that's not a fluke. It's not a fluke, that's how it works. That just tells you how many outcomes you'd have to have, and that's all you're looking for. So I moved some stuff. I sold my house a month ago, moved some stuff into a storage unit temporarily until I decide what to do with the stuff. And when I went to the storage unit, they say, well, they offered, they sold locks, type of padlock to keep your stuff from being stolen. So there are 3 kinds of padlocks I got to choose. One was with a key. One was the, like the high school locker room kind of stuff, turn it to the right, turn it to the left, turn it to the right. it only had one right answer. The key is just opens it. The combination padlock that they offered me on that one too was there's one right answer. And the one I bought actually had what they call tumblers on it. You know, they're much more expensive, but I have a chance. I can change the combination to anything I want. So every day, if I wanted to change the combination, I could. There's a key to the side. You turn it, and then you spin your tumblers to your combination, and you lock it, and now that's the new combination. That's the one I bought. So I'm curious, as in this math class, well, how many days, how many different combinations, how many days could I just turn out that I could have different combinations? How many days? How many years? And so if you think about the tumblers as like over here, choices, you know, here you had a choice, sleeves, color. Think of the tumblers as choices. The number of choices that I have for tumbler number one, it goes from 0 to 9, by the way. You got to be careful of this one. So there's actually 10 choices. So see, here's a combination I could set it for. I can set it for that, or I can set it for that, and lots of others. So there are 10 choices for the first dial or spindle, and there's 10 choices for the next one, and the next one, and the next one. So if you looked at the pattern from the previous problem, you just multiply straight across. There would be, I would have 10,000 total different combinations, total. And you'd say, oh, well, wow, Jeff, there's 365 days in a year. You can do the math on that. I think you're good for a while, but 10,000 combinations divided by 365, plus, of course, there's leap year. Yeah, well, 27 years. I'm good. Plus, 27 plus years. That's what you're looking for in these problems. How many arrangements? And that's what you'd box. Okay, another one, license plate. So the state of California has 7 spots. 7 spots. Now, you guys know this. You need to get your license plate. If you just order your license plate because you just bought a brand new car, you bought a used one, let's say a brand new car, and you say, hey, pick the numbers for me. They're going to give you 7-letter numbers. They won't put any blanks in there, my understanding. Now, if you want any spaces, like I just want 2 letters for my license plate, that's it. I want my initials, my first and they'll say, well, we have to see if that's taken first. And if it's not, and if there's no other rules, sure, go ahead. So you'd have blanks there. Or the little wavy hand, or some other symbols like the heart and things like that. They have those. There's my personalized license plate currently on one of my cars. That's an X, of course. Think of that as times, like a math problem. 3 times, or 3 nyucks. Three times nyuk is 3 nyucks. Nyuk, nyuk, nyuk. Okay, thanks, Joe. You know, he says, oh my gosh. Yes, I am a Three Stooges fan. Here was my other one that I had retired because I got in an accident and it crunched my car, so I just kept the license plate. I stole it off the car. Hey, Mo. Hey, Mo. Hey, Mo. There was a gap right there, space. Hey, Mo. Anyway, you can get personalized license plates. This problem up here, it's like the same thing. Well, how many license plates are there in the state of California? Could there be? Too many rules, though. Like sometimes you cannot take a license plate. Like the one I said, hey, Mo, where did it go? Even though I stole the license plate, is it available for anybody to use? I don't know that. Like the letter O and the digit 0, they look the same, so they're not going to let you put. And I think there was some other rule. Anyway, there's some other rules. let's say there's no rules in the Bahamas. Since it's a small island or set of islands, not very many people, they only need 3 slots for their license plates. Let's say you have to fill them all up with something. And what are we going to fill them up with? The law says no repeats. You either got a letter or a digit. So let's assume their letters are the same as ours, A through Z, and it's only capitalized. So there's 26 letters and 10 digits. So the law says you can't repeat anything though. So you actually have 36 choices for the first position, any of the 36 choices out there, letters and digits. But after that, no repeats. So you only have 35 left to go here. And now you've used up 2 of those 36 choices. There's only 34. And you multiply that out and you get some number. And all that means is, do we have enough license plates for the future for drivers? Yeah, I don't know what the population, and of course you got rental cars and things like that. I just don't know. But maybe they don't have really, maybe they have 7 slots just like we do too. Maybe they do. I don't know. I didn't do that much research. It's the kind of problem. Okay, no repeats here. Let's say the law, same one, says the first spot has to be a digit, has to be. All right, well, there's 10 there. The second spot has to be a letter. And the last spot can be anything you want, including repeats. So they multiply that out. Okay, with that law, there said there'd be 9,360 different license plate digit numbers. So again, it's a process that you've just learned from me right now. The textbook, when you read the textbook, it's the first 1, 2, 3 a page, 1, 2, or 3 pages into it. It'll say the multiplication counting principle or rule, counting rule. And they do a couple other examples. Okay, and the next thing you'll see from me and also in the textbook is this notation called factorial notation. All of you claim to have seen that because that's now also something we'll use in this course. All of you should claim, well, okay. If you took high school, the pre-course for this, advanced algebra, I just don't know what high school you came from, nor other college. So it's a possibility that you came in without that knowledge. If you took SRJC's, say 156 or the old 155, yes, we cover that. So there's some of you might not have seen the exclamation mark, factorial, like this, 2 factorial. Beyond this course, because most of you, this is your last course, you'll probably never see it again. So this is the one, time. If you're planning on taking a higher level math course and going the other pathway, it does come up again. So you're just learning a new procedure, new notation. Here it means sum. Learn that. Here it means you're going to take the original number, like 2. Let's go down here to 7. That's 7. So you're going to take the original number, and this is multiplication all the way down. This is multiplication. So as you can see, it just kind of goes down in order. 7, 6, 5, 4, 3, 2, 1. Not very interesting right now. You'll see how it's applied in this section, but not very interesting right now. Well, good thing, Jeff, you didn't do this. It's like I'm doing. I mean, that's something we investigate. I could ask you that on the exam. Could. I have to show you a way of handling that, because if you do 70 times 69 times 68, you're going to probably make a mistake typing it in. Anyway, this one here, the result, if I haven't made a careless mistake typing it, 5040. This one here, 2. This one here, 1. You always stop at 1. Always stop at 1. And this one is weird. Accept it factorial. No. Accept it. You might struggle with that. That's good. A couple of you at the end of class, you can say, I really don't I'm going to challenge you, Jeff. Why? Why? So then stick around after class. We'll debate it. We'll talk about it. We'll talk about the why behind it. But right now it's true. Let's see, something else related to that. Why?
So Jeff, just to clarify, that means every time 1 factorial and 0 factorial equals 1?
Yeah, for 1 factorial, look at the definition. If you put a number right here, you're going to start with the number and keep subtracting 1 as you go down. So you're just going down in order until you get to the number 1. So you always stop at 1. So if I put in a 1 right here, well, that's it, because I have to stop at 1. This one's weird. That's all. It's just weird.
That's just a exception.
Right. You just accept it. It is true. I'm going to show you why right now with a nice button on your calculator. Because like 70 factorial, you don't want to do that, on your calculator. 70, you're going to make a mistake, first of all, and that's just tedious, and what a waste of time. So someone's programmed your calculator for you. Isn't that nice? So in your calculator, if you want to watch how I'm doing this, you got to put the number in first. So if I want to check 2 factorial to be 2, put the number 2 in first. And then you're going to find the exclamation mark. Now there's at least 2 places, maybe even more, to find where the exclamation mark is. One place that you can find everything, by the way. Everything can be found, a little glary, sorry. There, that's better. Right there is called catalog, and it lists every possible symbol that you could ever, and words and phrases that you could ever think of. And it's alphabetical. So if you did that, which is second here, and then hit that key, see, I'm saying there's everything you can think of. And you keep toggling around. Oh, you can go backwards too. Watch, I'm going backwards. Yeah, pi and all those. What are those things? I don't know. Everything you can think of. Everything you can think of. Yep, everything. Yep, everything, including, eventually you'll get there. Eventually you'll get there. It takes a while. It's got to be a better way, Jeff, to get there. Oh, there. Oh, look at that. There it is. That's the exclamation mark. That took a while. So if you grabbed it, there is a faster, easier way to show you here in a second. But if you grabbed it by hitting enter, see, then it says, hey, 2 factorial is 2, which is true. I mean, it's right here. 2 factorial is 2. Okay, here's the other way of doing it. Go 2, and to find the exclamation mark, here's a math button right here. So after you type in your number and you hit math, okay, You see the menu choices. Go over to PRB. What do you think PRB stands for? Anybody? Problem? Good choice, but that's not it.
I'll take
Yeah,
probability for
Probability.
100
Yeah,
ounce.
yeah. So, gosh, everything we're going to use today is under probability because it's chapter 5 probability. I'm going to scroll over, hit nothing yet. You can see number 4 is the exclamation mark. There you go. That's a little faster. So either hit 4 or just scroll down and hit enter. And hit enter again. Of course you get to. Of course you will. So how about the 70 factorial? Okay, 70 exclamation mark. Go over, grab, enter, error. That is so big, the calculator can't even handle displaying that big number. It's big. So 70 times 69 times 68, all the way down to 1. It's so big. Okay, watch this. I'm going to see how far we can go. Let's try 50 factorial. I think it might work. I think 50 might be okay. Oop. Yeah, 50 is okay, and you can go higher than that. Now, I can't remember if in this course we've yet seen this. I know my other algebra-based courses, we have already seen this in different scenarios. So I'm telling you what that means. It's scientific notation. Now, scientific notation, all of you should have seen it in your beginning algebra, even at high school. That's just a real basic. So unless you came from a country that doesn't teach it for some reason, so there might be 1 out of the 25 of you, maybe, but everybody else has seen it. All right, so what does that mean? If I wrote it over here, let's say 3.04 as an example and went E64. Now in high school in our algebra, they don't put E. E maybe stands for exponent. It would be 3.04 times, and it's a base 10 raised to the 64th. That is how you usually see it as scientific notation. The E is calculator language. Whoever developed the calculator didn't create it so it looks like this. It looks like that. So you need, from here on out, this is being recorded, by the way, too. Sound like one of those telemarketers. This conversation is being recorded. Mr. Mrs. Telemarketer / Verizon, even all those companies do it. I don't want to be recorded. I've done that before. And they say, well, then I can't have a conversation with you. Hang up. Boop. They hang up. True story. And it was a Verizon as well. I was debating their billing on me and debating, and it came down to, I don't know, $29. They were wrong, and I had proof. And I spent, I don't know, seemed like 24 hours total on the phone, getting the level of, I want your supervisor, and then I got their supervisor, and then I went to the next supervisor, because I could have, someone says, why are you getting such a stressed out, high blood pressure, whatever, over $27. And I says, because of the freaking principle on it. They're wrong. I'm not going to pay that big giant company extra $27 because I want to get out of Verizon anyway. Stupid company. Anyway. So the guy goes and says, this conversation being recorded. I says, good. You need to go back to, and I kept all the dates, everything. You need to go to September 24th at this time. I kept logs, everything, and listen to that recording, because you recorded everything. Since you won't talk to me unless it's recorded, you go back, because it says there, that person says, oh yeah, I agree. $27, that should not be there. Let me get you to the next person. And then what happens usually? The line drops. What is going on? And you never get back to the same person. So I have to start the conversation all over again. Anyway, I won it. $27. Took me 24 hours. Was that? That's $1 per hour of my time. I get paid a lot. I told them this, you know, you're wasting my time, but I'm not giving up. So the point is, I have no idea. I just rambled on. Oh, scientific notation. Yeah, that's not it. Big number. Yes. Remember how to do scientific? Oh, this is being recorded. That's the reason. I've just recorded this, and that's 10 minutes worth of fluff. Recording this, that's a big number. Scientific notation. All of you needed to have seen that. You moved the decimal over 64 places. 1, 2, and what do you do if you run out of room? You just keep moving it over and stick a bunch of zeros on the end. So that's just a huge number. Huge. I'm going to see how far I can go. I did 50. How about 60? Oh, I'm getting closer. Look at it. When it gets to 99, then it stops. That's the highest. So there's going to be a limit. 70 factorial didn't work. It was just too high. So don't worry about it. You're not going to get that big on the test. Oh, what about this funny one? I think Caitlin was just saying, do you supposed to believe that? Well, calculator says it is. Whoever programmed it said it's supposed to be. So I guess the calculator knows everything. Siri knows everything. Google has an answer. And Wikipedia is truth. Don't think so. But at least the calculator is going to say 1. So the question would be, and that's where I can debate it with you or discuss it. Why is it 1? Why? It just is. It just is.
Hey, Jeff, I have a quick question. For 5.2, are we skipping that? I know we're into 5.4 now, but I don't think we went over it on Tuesday.
I hear your question. Give me a second. I'm bringing up something. I'm going to show you something. Okay, I see here. I think that was Caitlin that said that. I'd say, Caitlin, do some research. I know you would do this. Do some research. Something out there kind of indicates the answer to your question. Somewhere, something out there. Whether it's recorded or, and I'm just going to say it's documented. And you might say, all right, well, here's your homework. Do you see 5.2 in there?
No.
Oh, well, then your question might be, well, Jeff, there's no homework on it, but you have it in your packet. Are we responsible for anything in there? That's a different question. So 5.2, 5.3, there's no homework. What are you going to do? There's nothing for you to work on. So why did I put it in there? There's 2 little baby topics. And I'll go back right now since you brought it up, that you'll hear me speak about in the future on a regular basis. 2 little baby topics. But is there homework on it? No, there's no homework on it. Let's go back here. So I'm glad you asked that question. You know, you guys always go back. Hey, Jeff, do we get something to throw away for a homework? Do we? And I'll say, I don't know. Go read the course outline. It might be there. If it's not there, I'd answer your question. But So I'm just going to go over here and say, well, what was it about over here that Jeff skipped this whole thing? And you're not going to do any of this stuff. The first page here, I'll highlight the things that you need, Caitlin. Okay. You know what the event is in terms of definition. You know what that is. Okay, there's the word complement again. Forget this for right now. Oh, definition of complement. Okay, this might be like a foreign language garbly-goop. You know what capital S is. You know that. Okay, that little notation right there, if I did, instead of A, it might make a little more sense to you. I did E, and then you put a C somewhere. Sometimes they put it down below, put it above. Looks like they put it above. The complement of an event, E. Usually we use the word E for event. So C means the complement of that event. That's it. All right, now what? Negating, what the heck is that? Any of the description of the words, negating. Now, okay, what are we, rolling a die? Yeah, rolling a die. How do you negate rolling a 4? Getting a 4, how do you negate that? Anybody? How do you negate a 4? I get a 4.
Just make
Okay,
it
you're
negative
little-
4. Take
Okay.
it out.
Okay, good. Okay, I heard negative 4. I heard take it out. Let me do a different one. What do you think negating rain? It's going to rain today. What do you think negating me of that means?
The opposite, it's going to be sunny.
Okay, there you go. That better. Okay, so negating, so rain, sunny. Now, what about cloudy? Okay, how about this? Rain, not rain. That's what it's negating is. It's not that thing. So rain, not rain. On, not on. It's off. No, I know that. On, not on. Okay, the number 4, not the number 4.
So wouldn't it be 5/6?
Okay, you just gave me probabilities. I'm not even going with the probability right now. I heard someone say 5/6. Now, if I said, what's the probability of getting a 4, you'd say, well, that's 1/6. And I says, well, what's the complement of the probability of getting a 4? Then you'd be right, 5/6. It's whatever the difference is between the probability that was given and 1. But if it's just a phrase, you'd say the complement is not rolling a 4 on a, of course it's a fair die. And maybe that's what you're saying over here, whoever responded, because you saw the probability. So if it was the probability of rolling a 4, probability of a 4 is equal to 1/6. The probability of not 4, like this, just abbreviate, would be 1 minus 1/6, which is your 5/6 that someone said just a little bit ago. You know, it's the leftover. So yeah, eventually we will, you're right, we will, whoever said 5/6, we will bring it into probability. Not in chapter 5, but eventually in, I don't know, 6 and beyond possibly. So complements of the probability, that'll be the big thing. Yes, complement of the probability.
So do we need to know 5.2 and 5.3 for the test, or do we just?
No, well, yes, but no. See what I highlighted?
Yes,
Okay, you got to know complement.
okay.
So if I said, what's the complement in probability language? What's the complement of 1/6? What would you say then?
5/6.
Right. What's the complement of 40% as probability? What's the complement of 40%, anybody?
60%.
60%, Right, because you can only go up to 100%. See, that's how complements are working with probability. What's the probability of 0? Probability, 0. What's the complement of impossible? Because that's what 0 means. Impossible. What's the not
Certain.
impossible? Not for sure. Yeah, absolutely, or whatever. That would be the complement. Complement. So what's the number? The complement of 0.
100.
Right, as a percent, 100%. So I would say right now, that's all you need to know. There's no homework, just know how that works. Union, intersection, those are symbols in your packet. That's all you need to know right now. They're in your packet towards the back with the definition. I've been known, I forget, I think I did that your first test, but I might throw a few of those, and I know I screwed up, didn't I? The answer. And I fixed it. But to throw out either the symbol and what's the definition, that's right out of your packet in the back, or give you the definition and then you have to pick a symbol or true, false, or something like that. And the big reason is because of these 5. Everybody struggles with this at one level or not. Those 5 symbols. In algebra, it's coming back to haunt you guys. Because coming up, might even be in this section. It might have been last section, might have been 5.1. And maybe even in the next quiz, I think it is, the little quiz you're going to get today. It throws students because they don't know what the words, the phrases that go with this, like this phrase right here could be one of many, could be less than or equal to. That's the common one. But there's another one like no more than. So whatever happened on the last little quiz in the last class, students just said, oh gosh, I didn't know it was even less than. They're not getting it. So in the back of your packet, the definitions and the symbols are there to help you. Hopefully you'll get it better as we go through the semester, I'm hoping. The more you practice, the better you are. So know that's a symbol, know that's a symbol. That's all you need right now. That's it. Okay. Don't need to do anything else, even though I put it in here. You know, it's like, what about the Venn diagram, Jeff? Well, I think it's interesting. Some of you have seen it. That's about it. Don't need, you know, like mutually exclusive. What does this mean? You know, there's that symbol. Well, don't do anything yet. Don't worry about it. Nothing on the test. If there is something, I'll come back to it in 5.2, 5.3. If there is something, I'll come back to it and tell you. Okay, Caitlin, thanks for asking that question. I think it was Caitlin originally. Okay, so, oh, well, here's a formula. I'll bet you $1. If I knew your background, you know, what your math classes were, I'll bet you $1 that your instructor said, well, you need to memorize some things. You need no notes on the test. That means you got to memorize. And one of the formulas, that was a very famous one, is slope-intercept form. I'll bet you $1. Everybody had to have no notes, so they got to remember this. You just have to remind it on some of it. This one here was y equals mx plus b. Okay, that's a formula. That's an equation or a formula. I would say there was probably in beginning algebra, there probably are 4 big major formulas that I, as an instructor, have an expectation that, hey, you need to know this because you're going to use it in the next 2 classes. And so know it. I'm going to test you on your memory. That's just one of them. So this one here is a formula. No, you don't need to memorize it, because in our class currently, under this whole COVID stay in place Zoom stuff that we're stuck with, you've got notes and a textbook. So you just need to know what this means and how to use it. Now, if we weren't in this scenario, would I force or create or ask, demand that everybody memorizes this? I've done it in the past. And notice that the formula includes factorial. And that is a symbol in your packet. That right there is a symbol you need to be aware of. And absolutely, in the past, I had portions of my test, 10%, 15%, which was all about symbols, no note, no calculator, no book, nothing. And 10 or 15% of their test was about memorization of the symbols and definitions. You don't have to. That might be one thing to say, well, thank goodness. But you got to know where to find them and what they mean. So there's the symbol. And the word for word definition that would go here is on the next page over. I've done this so many times with you guys. Seems like it. I know I have 2 stat classes, but it seems like I do it every time. So that's number 13. Just the word permutation. Not permutations, plural, permutation. So that's what you're going to learn right now. What's a permutation? Well, a couple of the little bullets or rules. This is probably the important one right here. Order is important. Order is important. Now, when this one here, the second bullet up there says repetition of items is not allowed. If you remember the license plate from the Bahama problem, there's 3 slots and you can't repeat anything. That's the repetitions is not allowed. That's a permutation. Go back over here. You can't repeat anything. There's no repeats, no repeats. This is a permutation right here. How about this one, Jeff? Oh no, I can repeat anything I want, so that's not a permutation. How about this one? No, that's not a permutation because I can repeat, like over here, there's a repeat of these. No, that's not a permutation. This is different because this is 3 completely different things right here. That's different. So some of this is going to be challenging because you're trying to say, well, gosh, I'm supposed to figure out which one is which type of problem. Yeah, it's challenging. So I would say, gosh, YouTube is another place to find help outside of this class and my recordings in the textbook. Google, YouTube, Google permutations. Then Google the thing that's called combinations, and then Google and see what others say about it and their examples. That's just an idea. All right, how does this formula work? Well, okay, N is the total number of numbers. So for instance, the Bahamas, there were 36 digits and numbers. So that would be N, 36. Now the R, the next number, is how many slots or how many spots or how many things are you looking at? And we only had three things on the license plate. So this would be 36. This would be for the license plate. Well, I can show you over here. To get this number somehow, this would be 36 permute, and there are 1, 2, 3 positions, 3. So somehow the formula should work and give me that answer right there. But Jeff, this is so easy. I do it yeah, I know exactly. I wouldn't use the formula on something like this if I knew what I was doing. I wouldn't. What if there were, instead of 36 slots, there were 30, excuse me, what if instead of 3 slots, there were 30 slots, like there was a license plate for the world, and they had to have 30 spots. Well, to put that in your calculator, 30 numbers, 36, 35, 30, yeah, so why not do something like this? 36 permute 30, and you'll get your result that way. All right, so, well, here's the formula. So I'm even gonna write it over here so we can use the formula. What if I had 36 permute 3? That means here, 36 factorial over 36 subtract 3 factorial. So 36 factorial Didn't I show you where the factorial key is?
Yes.
There's a way to do this pretty easily without a calculator, but all of you have a calculator. I would highly recommend that you check your calculator batteries so it doesn't fail you. You're not looking around for batteries. Because remember, you can't use anything digital. That you're on your honor, you've signed a statement. If your batteries go out and says, well, I'll just find one on my phone. No, that's digital. You can't do that. You can use your calculator, but not, oh, I'm going to find one on the internet. You're not supposed to do that. Oh, how do you find out batteries are dead or not? If you go, you could Google this too, YouTube. How do you know if your batteries are dead in a TI-84? It's amazing what you can find out there, and someone's going to have the answer. Anyway, this is one way of checking. If you go alternate, second up, second down, second up. It's like, where would you find that, Jeff? This is what I was told, and it works. Second, maybe the instruction book that, it's like this thick. Nobody reads the instruction books. So I go, watch, there'll be a number that just kind of blinks, appears. Oh, I saw a little phantom number. You guys see that? Oh, I can't see it. Okay, I can see it. Second up, second down, second down, second up, second up, second up. It's toggling between 5 and 6. I'm seeing it 5 and 6. If your calculator's on 7, you need to change batteries. On occasions, some models, the newer ones, will give you a warning. It'll say low battery, change your batteries. It'll just have display it here. Oh, okay, that's a nice warning. Some other calculators don't have that, and then all of a sudden you turn it on and nothing comes on. So then you got to find batteries. And of course mine, I changed mine out here. Some books will be, yeah, gotcha. Okay, thank you. Some books, not books, some calculators have a plug. Oh, this one's got a plug here too. I don't know if you can see it. Where am I? Here. Oh, here. Has a plug where you can charge that sucker up with the, so backup batteries. Some of them have batteries or backup batteries. Anyway, so if I'm here and I want to work this out with the calculator, I know my batteries are pretty strong. I'm going to go second. Excuse me. I have to do 36 first. Now, my calculator has the ability, I've got a model in software that has the ability of actually making a fraction. If you don't, if you want to see me after class, I can show you how yours might. If you have an old model, it won't do it. So what I'm trying to say is I'm going to go second, this, and look at, I get the little, what I'd hoped, nice to have a little fraction feature right there. And then I get just to type in 36 with the exclamation mark. I'm not going to answer, Jeff, what did you do, until after class today. Let's see, math. I mean, there's other ways, plenty of other ways to do it to get your result. What was it, 33? Math. Okay, enter 428. All I'm doing is checking my answer. 42840. 42840. 42. There it is. 84. So okay, it works. That thing works. Oh well, that formula works. Now I'm going to show you another way of doing it, which is actually even better than what I just did with the formula. See right here, calculator under math, M-A-T-H, and then PRB, PRB. Math, PRB. Math, PRB. Math, PRB. Math, PRB. You probably saw it there for a second. Oh, there it is, number 2. Oh, interesting. Yeah, you don't have to do what I just did at all. You know, like the formula. Ultimately, you just have to know how to use the button. Now, if you said, well, I'll just use it. I want to do 36 permute 3. Okay, I want to grab that. Unfortunately, this answer means you have to have a number there. You have to put the number first. You have to do 36 first. Now you know. Clear it up. You have to put the number first, 36. And now you go find the NPR. So put the number first, put the N first. NPR, okay, this is good. 36 goes with the N. The next number goes with the R. And I want 3. See, this is N, that's R. Hit enter, and there's the same number. I'll do that again with these other problems. Watch. Okay, 8 permute 3. I know, because I know the pattern, I know I start with 8 and I have 3 slots. I know that, and you guys are just learning that. So that's got to be 7, 6. I know that. You know now that if you have a permutation, you start with the number 8 and you write 7 slots. Well, there's 2, 3, 4, 5. Are you kidding me, Jeff? 6, 7. And then you put the numbers in order. 7, 6, 5, 4, 3, 2. See, there's a pattern here. So you know that now. But to come up with just the answer, you don't even need to do that. All you have to do is just use your calculator. And you do 8 first. So 8 permute 3. 336. If you took 8 times 7 times 6, it's 336. If I did 8 times 7 times 6, 336. And like manner, so the rest of them just easily go 8. Permute 7. 40. 8 permute 8. 4320. Hey, look, it's the same number. The reason is you're just adding one more square to this. You're adding one more square. What's the last square going to be on this one?
1.
Right. Yeah. Oh, just multiply by 1. You still get the same thing. So this one here would be 43,220. And you go over here and you just do 8 permute nothing, whatever that means. Okay, so you go 8 permute 0, and you get 1. Okay, the last example in this permutation is giving you kind of well, it's pretty common type problem. They talk about a committee. Your textbook will do the same thing because it's a good illustration. For instance, I see Joe, Caitlin, Jennifer, and Arthur right now. I see 4 people on my screen. And so let's say those 4 people are running for office. And there is a vice president and a president. Now, whether you want to or not, or believe it, that president is the most important, so everybody wants to be president. Because if you're running for office, everybody wants to be mayor, vice mayor, whatever you want to call it. So in this case, I'm going to use J for Joe, K for Caitlin, J for Jennifer, and A for, Okay, so letters are different. I'm going to use last names. S, M, H, M. Shoot. There's duplicates. All right. So Joe is J-O, and then Jennifer is just J. So president, vice president. President, vice president. Joe could be president and Caitlin vice president. Joe could be president and Arthur could be vice president, and Joe could be president and Jennifer is vice president. Well, I think we've ran through all the options because Joe can't be vice president and president at the same time. Can't do that. So no repeats. That's what they're saying. There's no repetition. All right. Well, then Caitlin wants to be president. Sure. Joe could be vice president. And then, but with Caitlin being president, so is Arthur and Caitlin and Jennifer. President, vice president. Okay, I think you're starting to see a pattern. Arthur's president with Joe and Caitlin and Jennifer. And finally, Jennifer's president, VP, with Joe, Arthur, and Caitlin. So it appears that there might be 1, 2, 3, 4. 4 times 3 is 12. It appears to be 12. The sample space is 12. And then I could ask probabilities about all that after to find the sample space just by counting. So how many different arrangements? There would be 12 because I just came up with them just out of my head and wrote them down. But if I did it as a permutation, now you don't have to on the exam. By the way, if this question was on the exam, all you have to do is pick the right answer. I don't have to see process. So if you pick 12 and that was the answer, good for you. However, if you want another way of maybe considering, and it's a permutation, you'd say there's 4 people total, and how many boxes, how many positions? There's 2. So 4 permute 2 ought to give 12. 4 permute. Permute. 12, there it is. Order is important. See how order is important. Now we'll come back to this in a second with the last topic, which is combinations. Okay, and here are the letters on the problem I had, but not with our students right here. Here's the letters A through D. That could be president, vice president. Combinations. Okay, the idea is 4 people are interested in being on a 2-person committee. There's no president, vice president. There's no mayor, vice mayor. What's another one where order is important? Oh, the Giants, baseball, okay? And I think they're in the division where I'm not following baseball for my own personal reasons, but I've heard that the Dodgers with this crazy, weird season that I just don't believe in it, because what's the World Series going to be with 60. Not all the players are playing, blah, blah, blah. But they're still playing. I still heard through the news or whatever that the Dodgers are in first place. And the Giants have a chance for, let's say, second place. So first and second gets to the playoff, first and second. But there's 5 or 6 teams in that division. So how many, that's first and second, that's ranking. Anything with ranking is order is important. Order is important. First place, second place. Now, this is not ranking. This just says, hey, 2 people can be on the same committee. For instance, those are the same 2 people. Nothing about presidents. That's the same committee. You cannot double dip. Oh, all right. Well, then count up how many doubles are. I think there's 6. Okay, so there's 1. Okay, so there's a duplicate. I'll scratch that one off. Okay, where's this one here? This one is AC. Okay, so I'll circle and scratch off. I'll count the circles. Okay, AD, DA, DA, DA. Nope. BC. Okay, sure. BC is our CB. Yep. Nope. BD. Okay, I don't want to copy that. BD. BD right here. And right here. Here. Okay. So 1, 2, 3, 4, 5, 6. Sure enough, there's 6. Sure enough, there's 6. So it has its own formula. It's called a combination. Order not important. To get that 6 over here, order not important. Got its own formula, which I'm not going to demonstrate. I'm just going to show you on your calculator. You would want this one in your calculator. So on this would be 4, choose 2. Better give me 6 when I'm done. 4, choose, not permute. 4, choose. It's there. Oh, there it is, number 3. And then 2, and it's 6. Six, choose 2. It's calculator keystroke. I'd probably give you one problem. That is it, because it's a pure calculator on the test. Hey, what's 6, choose 2? Use a calculator, get it right, move on. Might even be worth only 1 point because it's like a no-brainer. Got to know which one to pick though. Was that 5? Oh, 2. I wanted 2. Okay, 15. Okay, I'm gonna do it again. 6. 5. Okay, answer 6, whatever that means. And then 6. 1. This would be like, okay, I've got 6 candidates interested in 5 committees, 5-person committee. 6 candidates, can I list them all? Well, there's only 6 of them, and yes, you should be able to list them all. If I gave you 6 names, could you give me the sample space? Because there's only 6 outcomes in the, yes, you could. 15 is kind of pushing it. I don't know if I'd ask you that on the test. I might ask you like 12 or less. Now, how would I ask that on a multiple choice? I could give you a scenario. Let's say, well, even this one here, that's 6. I can give you a scenario that says there's 6 people and there's 5 positions. And here's the people. Pick the sample space that's correct. And you go, oh, you'll have A, B, C, D, and they're all outcomes. So you'd have the name or the letters in the outcomes, and there can't be any, here, there can't be any repeats, because if the repeat, that's a bad one, you throw that one out. So here, I'll show you what this is. Okay, fine, here. All you have to do is just go like this. This is the same committee. Okay, A, B, C, D, and E. There's an F, by the way, that would be 6. Okay, that's one committee. Jeff, how about B, A? Okay, so far so good. C, E, D. Not good. You've just repeated this in different order. You can't do that. Not good. Well, how about, Jeff, how about B, A, C, E, F? Remember, there's a 6th person called F. Oh, yeah, that'll work. Well, then how about A, B, C, D, F? That's different. I think it's different. Yeah, there's no E here and there's no A there. That's different. I have 3 more to go. So what I'm saying is I could give you this problem with that scenario and give you 4 choices, A, B, C, D. And maybe one of the choice has more than 6. Maybe it only has 3. Maybe one has 10. Maybe one of them has, 2 of them have 6 and one of them has repeats in it, just so that you can see what the concept of combinations is. Okay. So the very last thing that I'm going to show you is how this is connected to something I think it's kind of interesting and fun, and that's all I got for you today. Interesting and fun meaning, where is it used? No, really, nope. I think it's just fun. Pascal's triangle. Okay, I'll just say it. Or pyramid. Honestly, I don't know in what scenario or what industry. I used Pascal's triangle to solve this problem. I've never heard anybody tell me that. I'm curious with, let's see, I'll do a show of hands here. I see about 25 of you. Raise your hand if you have ever heard of Pascal's, you've heard of the word Pascal's triangle. Okay, 1, 2, 3. Okay, I'm seeing about a third, less than that, a fourth of you. Okay, thank you. So those of you, you say, I've heard of it, but I forgot. That's possible, likely. Those of you that have never heard about it, well, this is new. A lot of patterns to it. So I'm going to introduce you to it. Show you how this works. Combination is embedded in here. Now, if you wanted to ever create the triangle, it's very easy. You just need to know that you start with a pyramid with a bunch of 1s. So you have a base of 2 1s, and the gap in between has the 1 at the top. So 1 at the top, and then 2 1s. After that, you just remember on the outside of the pyramid, and you don't put it right below it, you scoot it over. Okay, it's always 1s on the outside. And to get the next number in between is adding the 2 numbers above it. So in this case, 1 + 1 is 2. See, that's what it is. Okay, now, how do you do the next one? It's called rows, by the way. This is just row number 2 that I just did because I see the number 2. The next one is row 3. So this is row 2. Row 3. Okay, so you put a 1 out there, put a 1 out there, and you put, hey, there's a 3 there and a 3 there. Okay, and then if you look over here, sure enough, 1 3 3 1. And you do row 4, you go 1, you put a 4, there's the 4, row 4, but this one's 6. That one's 6, you just add the 2 numbers above it, and this is 4 and this 1. So very symmetric, very symmetric. This would be 1, there's your 5, row 5. Row 5 is there. This is 10, this is 10, and then you go 5 and 1 again. And over here is 1 and a 6 and a 15 and a 20 and a 15 and a 6 and a 1. Okay, if I want to check that down here, make sure I didn't make a mistake. Okay, 1, 6, 15, 20, 15, 6, and 1. All right, now, this is called row 6. The previous page, if you look back there, which I will, had 3 problems, combination notation, 3 problems. You got 6, 2, 6, 5, 6, 0. 6, 2, 6, 5, 6, 0. 6, 2, 6, 5, 6, 0. 6, 2, 6, choose 2, 6, choose 5, and 6, choose 0. This is your row. Row. So now I know it's row 6. Okay, so I circled that row. And these are called positions. So this is your second position. Now here's the thing before I even count where the second one is. With Pascal's triangle, you always start with the number 0, or like the 0th position, and then the first, and then the second, and so on. You always start with, like this one here. Z-E-R-O, and then a T-H, 0th position. So this number right here is, or that combination turned out to be 1. On the other page, it was 1. It's that one, not that one. Anybody want to know and take a gander? It's kind of old, right? Take a guess, a gander. Take a guess as to what the notation for this one would be. A wild guess. Just take a wild guess. What's the first number going to be? That's not even a guess. That's a fact.
Six.
Yes. Okay. Now, wild guess on the next number. Anybody want to try that one?
Also 6.
I agree. I agree. 0th, first, second, third, fourth, fifth, sixth. Oh, that ends at 6. Okay, so 6, choose 5. Okay, 0, 1, 2, 3, 4, 5. So this one is that 6, not that 6, that 6. And 6, choose 2 is 0, 1, 2. Okay, so that's this one here. Interesting. I think that's interesting. Sometimes I use that in my advanced algebra class, or intermediate algebra class, and say, under certain concept, I have them use the Pascal's triangle only to answer the questions. That's the only sheet of notes they have. But with you guys, just know that it exists. Just say, hey, that was kind of interesting. Okay, so what's the big deal? Nothing. Combinations is a big deal. You got to know that. But okay, let's see. Let's see if there's anything else here. All right. Questions for me. Let me see if I've got something for you today in terms of a quiz. I think I do. Wrong class. Today's the 17th. Well, hold on a second. I'm going to try to find my